Welcome to the last video of Chapter 8, which is Section 8, using exponential and logarithmic functions. Today's video, you're definitely going to need a calculator. All of our examples are going to be word problems. So today, we're going to be looking at all the different equations we have and trying to determine for each word problem which equation do I need to use. So there's two main equations for today, the non-continuous equation and the continuous equation. The non-continuous equation you learned at the beginning of the chapter. It's the one that says y equals p1 plus or minus r over n raised to the nt. In this case, r was the rate, t was the time, n was the number of times per year, and p was the principal or starting amount. Okay, so that was the non-continuous equation. So that was the equation that we used for exponential growth or decay, when the growth happened every year, or twice a year, or once a day, or once every hour. So it wasn't growth or decay happening continuously. It was growth or decay that happened after a certain amount of time. And this was the one, remember, where n equals 1, except for compound interest. So n is 1 unless you're using compound interest. Now the continuous equation, this is for growth or decay that's happening continually. It's happening all the time. This one is y equals p e to the r, not to the r, to the k t. Okay, and this one should look familiar. It's very similar to the compound interest equation that we did in the last video, except instead of k, we had an r. Here, k is a constant. So it's just a number. Now, k varies based on whatever problem it is. So you're going to have to figure out what k is based on the problem. T is still time and p is still principal amount. So the main difference between the equations is whether it's continuous or non-continuous decay. So let's do a few examples and see how we do. So example 1, it says you have 50 grams of carbon-14 that decays at 13.5% per year. How many years will it take for 1/5 of the original amount to remain? Okay, so first thing I need to determine, is this continuous or not? Well, it says decays at 13.5% per year. That per year is what tells us that this is not continuous. So our equation is going to be y equals p, 1 plus or minus r over n to the nt. Okay, so p is our starting amount, which is 50. I start with 50 grams. 1, okay, this time it's decaying, so I'm going to be subtracting at 13.5%. Remember that you need to change that to a decimal. So as a decimal, that's 0.135. N is 1 because this is not compound interest. Again, compound interest, it'll say compound interest. N is still 1. Okay, and then it says how many years will it take? So that tells me that I'm looking for t. How many years will it take? I'm solving for t. I'm solving for time. This means I need to have a number for n. Well, it says how many years will it take for 1/5 of the original amount to remain? Okay, so if I'm starting with 50 and I want 1/5 to remain, 1/5 of 50 is going to be 10. That's what I'm going to put in for y. And now I'm ready to solve. I'm going to do a little bit of simplifying. So I have 10 equals 50 multiplied by 0.865 to the t power. That's because 1 times t is just t. And now I'm ready to solve, and I'm solving for t. So first thing that I want to do is divide by 50. These 50s cancel. 10 divided by 50 is 1/5 or 0.2. So I have 0.2 is equal to 0.865 raised to the t power. Now I need to solve for t. So there's no other simplifying I can do. There's no way for me to break apart that 0.865 to the t power in the form that we have. So right now my best idea is to switch this to log form. So there's two ways that you can finish this problem. I'm going to show you both. The first way is to turn this to log form. So this would be log base 0.865 of 0.2 equals t. And then I'm going to need to use the change of base formula. So this will be log of 0.2 divided by log of 0.865 will give me t, which in this case is 11.10 years. So that was one way to finish the problem. The other way is to take the log of both sides. So I'll end up with log of 0.2 equals log of 0.865 to the t. Remember that t comes out in front, so I have log of 0.2 equals t times the log of 0.865, divide by the log on both sides, so I get t is equal to log of 2 divided by log of 0.865, which is going to end up being 11.1 years again. So I just wanted to make sure that I reviewed with you both different ways that you could solve the problem. One, you could put it into log form and then use change of base, or you could take the log of both sides. In essence, you're doing the same thing, it's just whichever method that you prefer. But either way, it will take 11 years, or a little over 11 years, for 1/5 of the original amount to remain. Okay, so this was an example of non-continuous decay. We were told it decays at 13.5% per year. We were not told that it was continuously decaying. Okay, so let's try example 2. It says you put $2,000 into a bank account that pays 3% interest compounded continuously. How many years will it take for the amount in the account to double? Okay, so first thing, is this continuous or not? Well, it says compounded continuously. So I'm going to use the continuous equation, but it's the continuous interest equation. So what we did last video. So that's the y equals p e to the r t. And now I need to start filling in. Well, I'm told that I put $2,000 into a bank account. So that's my p, 2,000. Remember that e is a constant. It's a number in our calculator, so we don't need a substitute for that. I'm told it pays 3%, so as a decimal that's 0.03. And then it says how many years will it take, so I'm solving for t, for the money in the account to double. So if I put in $2,000 and it doubles, I'm ending up with $4,000. Okay, so my equation looks good so far. I only have one variable, which is t, and that's what I'm solving for. So now I'm going to solve. I'm going to divide by 2,000. Those 2,000s cancel on the right side. And I'm left with e to the power 0.03t. And then 4,000 divided by 2,000 ends up being 2. Okay, now I'm solving for t. I don't have any way of breaking that t apart from the e in the form that I'm in. So now I'm going to switch to log form. In this case, it's going to be natural log. So it's going to be log base e of 2 equals 0.03t. But we don't write log base e, we write natural log. So natural log of 2 is equal to 0.03t. I'm going to divide by 0.03. So in my calculator, I'm going to do natural log of 2 divided by 0.03. I need to make sure that I end my parentheses after that 2, so that I'm only taking the natural log of 2, and then I divide by 0.03. When I do that, I get t to be about 23.10 years. So it would take about 23 years for my money to double. It's always a good thing to ask, does my answer make sense? Does an answer of 23 years make sense? Yes. So in other words, you shouldn't get a negative, you shouldn't get a very small number. Okay, let's try another one. So it says the half-life of a radioactive substance is the time that it takes for half of the atoms in the substance to disintegrate. The half-life of carbon-14 is 5,730. Determine the value of K and the equation of decay for carbon-14. Okay, so this one gave us a hint. It says determine the value of K. So I know that I need to use the continuous equation. That's the only equation that has a K. So that's the one that says y equals PE to the KT. Okay, so nowhere does it say that that this carbon-14 is decaying continuously, but that's implied when I'm asked to find K. Now, let's fill in what we know. We know that E is going to stay E. We know that K is going to stay K because I'm solving for K. And then I need to think about what I have. So it says the half-life of a substance is the time it takes for half of the atoms of the substance to disintegrate. Okay, so let me pick a starting amount. It doesn't matter what my starting amount is. Let's say that I started with 100 grams. Okay, so then if half of the atoms are remaining, or half disintegrate, it means half are remaining. So if half remain, that means 50 remain. So I started with 100, 50 disintegrated, 50 remained. And then it says the half-life is 5,730 years. So it's going to be K times 5,730. And now I need to solve. So I'm going to divide both sides by 100. Those are gone. 50 divided by 100 is 1/2, or 0.5. So I have 0.5 equals E to the 5,730K. Now I'm solving for K. I kind of have hit a roadblock in terms of exponential form, so I'm going to change to log form now, specifically natural log. So this is going to be log base E, which is just natural log of 0.5 equals 5,730K. Dividing by 5,730, I get K equals the natural log of 0.5 divided by 5,730. In my calculator, I'm going to make sure that that natural log is only being taken of 0.5. So I'm going to do natural log of 0.5 and end my parentheses. Then I'm going to divide by 5,730. Okay, you're going to notice you get kind of a funny answer. It's negative 1.210 e to the negative fourth. So that's scientific notation. It just means times 10 to the negative fourth. Now, because we're going to be putting this back in an equation, I don't really think it's best to use scientific notation, so we're going to switch that to a decimal. Okay, so negative fourth means that I'm taking my decimal and I'm moving 4 places to the left. So I'm going to end up with 3 zeros, and then 1, 2, 1, 0, and then this is negative. So this is my value of K. Now you're probably asking yourself, why is it negative? You know, I didn't know that it was possible to get a negative K. Well, in this case, K is negative because this is decay. So anytime you have decay, K is going to be negative. If you have growth, K is going to be positive. Okay, so then it says even more, determine the value of K and the equation of decay for carbon-14. Okay, so our equation would be y equals PE to the negative 0.0001210 T. So P is your starting amount. So you can put in, I started with 500 grams, 1,000 grams, 2 grams. You also could write your equation as y equals E to the 0.0001210 T. In this second case, you would get an answer as a percent. So 5% remains or 10% remains, whereas the first equation would tell you the actual amount. Okay, so that was using the continuous equation. I want to go back up to the continuous equation and make sure that we put in, if k is negative, this is decay. If k is positive, this is growth. So I want to make sure we know that. Okay, so now if you would flip the page, please. Okay, so here are some examples that we are going to try again. 4, there's no stop sign, but I want you to try 4 on your own. So pause the video right now, try 4A and B on your own, and come back when you are finished, please. Good luck. Okay, let's see how we did. You buy a new car for $23,000. The value of the car depreciates at a rate of 16% per year. A says write a model for the situation. So the first thing you need to determine, is this continuous or not? Well, you should have noticed that it says the value of the car depreciates per year. That per year tells us that this is non-continuous. We are measuring the depreciation per year, not like every minute or every second. So the equation we're going to start out with is P times 1 plus or minus R over N to the NT. Now remember that this is not compound interest, so N is just 1. Okay, so P is going to be 23,000. That's how much the car is initially worth. It's depreciating, so that's going to be minus 16%, that's going to be 0.16, N is 1, and then 1 times T. If I simplify this, I get 23,000 times 0.84 to the T. And T in this case is the number of years that you have the car. So this is the equation that you should have gotten. Hopefully you did. Please remember that it's an equation, it's a model, so you should have a variable on both sides. You should have a y and you should have a t. B then decide when will the car have a value of 15,000. Now mind you, if you got A wrong, you're also going to get B wrong. So 15,000 gets put in for y. And I'm solving for t, which makes sense. I'm solving for the when. So you should have divided by 23,000. This does not turn out to be a nice decimal, so I'm going to leave it as 15 over 23 equals 0.84 to the t power. Now you have two options. You can switch to log form, or you can take the log of both sides. Now, in the first video we did about solving these type of equations, I took the log of both sides. So I'm going to stick with that method. So I'm going to take the log of 15 over 23, and that's going to be the log of 0.84 to the t power. That exponent comes out in front. This helped me because now I can divide by log of 0.84. So my t is the log of 15 over 23 divided by the log of 0.84. Now I need to be very careful putting this in my calculator. I need to make sure I always end the parentheses after the arguments. So the log of 15 divided by 23, end my parentheses. Then divide that by the log of 0.84 and end my parentheses. And I get my t to be about 2.45 years. So that's what you should have gotten for A and B. So hopefully you did. This is kind of depressing. If you buy a car for $23,000, it'll be worth $15,000, $8,000 left after only 2.5 years. So that's kind of depressing. And you all should probably have heard of that before. When you buy a car, it depreciates pretty rapidly. So hopefully you got those two right. It's nothing really new. You just had to pick the right equation. So let's move on. 5 is the next problem we have. Again, this one has a stop sign, so this is a problem that you're going to do on your own. I would like you to pause the video and complete this one on your own. Do both parts A and B. Come back after you are finished. Good luck. Okay, 5. A type of bacteria is growing exponentially according to the model, where T is the time in minutes. If there are 1,000 cells initially and 1,650 cells after 40 minutes, find the value of K for the bacteria. Okay, for part A, you should have gotten K to be about 0.0125. You know that K is going to be positive because we start with 1,000 cells and we grow to 1,650 cells. So this is exponential growth. I'm getting more cells after 40 minutes. If you did not get that, you did something wrong. It could have to do with your setup. Okay, now let's move on to B. So it says, suppose the second type of bacteria is growing exponentially according to the model, and it gives you a model. Determine how long it will be before the number of cells in this bacteria exceed the number of cells in the other bacteria. So it's saying this bacteria exceeds the other bacteria. So this bacteria is 50e to the 0.0432 t. That's exceeding the other bacteria, the first bacteria, which was 1000 e to the 0.0125 t. Remember, it was e to the kt, but we solved for k. Okay, and then it says, how long? So I'm solving for t. First thing that I'm going to do is divide both sides by 50. So those are gone. I have e to the 0.0432 t is greater than 20e to the 0.0125 t. Now I'm solving for t, so I need those t's on the same side. The t on the right side is connected to that e, so I'm going to move the e as well. I'm going to divide by e to the 0.0125 t. Okay, so that goes away. On the right side, I'm left with 20. On the left side, I have the same base, e and e. So that base is going to stay. Because I'm dividing, I'm going to subtract the exponents. So I have 0.0432 t minus 0.0125 t. So this becomes e to the power 0.0307 t, and then that's greater than 20. Now, I kind of have hit a wall in terms of where I am at this point. I can't simplify anything else, so I'm going to have to switch to log form. It's log base e, which is going to be natural log of 20, and then 0.0307 t. Now, we haven't used any inequalities when it comes to logs, so I'm going to just change this to an equal sign. And then I'll change it back to an inequality at the end. Now I'm going to divide by 0.0307 on both sides. I have to make sure that when I do the natural log in my calculator, I do natural log of 20, end the parentheses, and then divide by 0.0307. When I do that, I get t to be 97.58 years. So how long will it take? It will take at least 97.58 years. Okay, so if I go back, t was on the left side, so t is going to be greater. T is greater than 97.58. So 98, 99, 100 years, there will be more bacteria in the second type than in the first type. And that's kind of cool if you look at the information that we're given. The first type of bacteria starts with 1,000, and then it grows. The second bacteria only starts with 50, and it keeps growing. Well, after 98 years, there's going to be more bacteria in the second bacteria simply because it's growing so much faster. So the answer that you should have gotten is 97.58 years. Again, that's not something we've really done before, so if you got that one wrong, totally okay. Hopefully you now see how to approach the problem. If you have any questions, please make sure you bring them to class. Before I leave you, we have one last trivia question to do. So, it says, the world's tallest man was born in Illinois. Can you guess his height, weight, and shoe size? To help you out, I'm going to show you a picture of this man. So here is a picture of the world's tallest man and his father. I want to know what his height, weight, and shoe size are. Good luck and see you tomorrow.